还有所有媒体记者朋友们，大家午安。我们今天下午的活动将要在5分钟之后开始，我们请您能够尽速的入席就座，同时也能够提醒您将您的手机调为震动模式或者是静音模式。在您所佩戴的名牌的后方有一个 QR code， 我们也请在场的贵宾能够用您的手机来扫描一下 QR code， 帮我们填写线上的问卷。凭荧幕的截图到1楼，可以来兑换我们所提供的杂志1本。同时，各位贵宾，您现在身上所佩戴的名牌，我们等一下会进行回收。在今天下午议程完全结束之后，在您离场之时，我们会请我们的工作人员向您收回您身上所佩戴的名牌。同时也要提醒您，本大会并没有成立官方的 LINE 的网站或者是群组，也不会提供我们今天讲者的这一些投影片 PowerPoint。但是在官网上面，我们有许多的活动的花絮，还有今天活动的很棒的照片。如果各位贵宾有需要的话，可以前往多多利用。 Ladies and gentlemen, welcome to the 2018 COMPUTEX Forum on IoT. This afternoon's keynote speakers from ARM, Intel, NXP, Amazon Web Services, LITE-ON, and Microsoft will talk about the opportunities and future of IoT. To kickstart this afternoon's program, let us invite Lenore Lane, Executive Vice President of TITRA, to deliver her welcoming remarks. Please help me welcome Ms. Lenore Lane.
Thank you. Our speakers, distinguished guests, ladies and gentlemen, good afternoon. On behalf of TITRA, the organizer of COMPUTEX Taipei and the COMPUTEX Forum, I would like to express my sincere welcome and thank you all for joining today's IoT session. I believe with your participation and support, today's event will be a great success. IoT has rapidly become the most dominating tech trend and brought great impact on the economy by transforming many enterprises into digital business, improving manufacturing efficiency, and changing employee and customer engagement. It still keeps broadening its presence in many different sectors, such as transportation, healthcare, industry, energy, retail, and so on. In this session, we are honored to have 6 outstanding speakers from leading companies: Amazon Web Services, ARM, Intel, Microsoft, NXP, and LITE-ON joining us. They will provide their latest insight and applications. I'm sure what you are about to hear will be amazing and very beneficial to all of us. Once again, to visiting COMPUTEX 2018. I wish you all the best and have an informative afternoon, not lunch, afternoon. Thank you, thank you.
Thank you, Ms. Lin. Would you please remain on stage for group photo shooting? And we would like to invite the first 2 keynote speakers for the afternoon session to please go on stage for group photo shooting. Please help me welcome Chris Porthouse, Vice President and General Manager, Device Services ARM. And next, please also help me welcome today's next speaker, who is Satyen Yadav, the Director and General Manager of Amazon Web Services. So why don't we have another warm round of applause to welcome our guest speakers for the afternoon session. Once again, here on stage are our 3 honored guests: Ms. Lin, representing TITRA, Mr. Porthouse, representing ARM, and Mr. Yadav, representing the Amazon Web Services. So dear guest honor, can you please put your thumbs up for members of the press to take a few more photos? Thumbs up, please. Gentlemen, can you please put your thumbs up for members of the press to take a few more photos? Thank you for joining us today. Thank you. You may now return to your seat. Today's first keynote speaker will be Chris Porthouse, Vice President and General Manager of Device Services at ARM. Chris has extensive experience running hardware and software businesses, from mobile and consumer electronics to IoT and the games industry, building trusted and long-lasting relationships with customers at all levels. Today, Chris will talk about seizing the trillion device opportunities. So ladies and gentlemen, without further ado, I will now turn the program over to Chris Porthouse. Let us give him a very warm welcome.
Hi, 大家好. Hello, welcome. So we are entering a new industrial revolution, a revolution built on the power of data. Industry today can access vast amounts of data, and businesses are using this to transform not only their operations, but also how they interact and how they service their customers. So this transformation will have immense economic impact. McKinsey estimate that impact will be $11 trillion by 2025. And IoT will be the catalyst for this, from connected devices in manufacturing, in utilities, in logistics, and more verticals. So I think in the last 5-10 years, we've become quite comfortable with the idea of billions of connected devices. 3 billion smartphones, 2 billion personal computers, 8 billion IoT devices. But that's just the beginning. We see a future where we're going to have 1 trillion connected devices. And these will be deployed anywhere and everywhere. In light bulbs, making cities more efficient. In hospitals, reducing cost, improving the quality of patient healthcare. And even in the crops we eat and how crops are grown. IoT devices deployed in the fields. So this next wave of technology and business and even life itself will change for us. And this will be driven by this massive influx of data from devices all around us. But before we can harness the power of this data, we first have to get access to it. So as you are all probably aware, IoT is very much at the top of a hype curve. And deploying IoT at industrial scale is a huge task. Businesses want access to data streams that they can mine, but they're faced with some significant technology challenges. Managing the deployment, the security, and the maintenance of legacy devices, and then integrating those legacy devices and systems with new smart IoT devices is a huge challenge. Doing this at substantially larger scale than ever before, not hundreds of devices, but thousands, tens of thousands, even millions of devices. That scale is another major challenge. And how we handle that data, how that data is then delivered to analytics and other back-end systems is also critical. So within ARM, as connectivity experts, as compute experts, I think our challenge is to turn the potential of IoT into something that delivers meaningful business outcomes for all of our partners. So as an industry, we have to do a number of things. We have to reduce the time and complexity that it takes to get usable data from devices so that businesses can create value and they can see a return on their investment. And businesses we work with don't want to see a return on investment in the next 5 years. They want to see that return on investment within 12 months. There's a number of things we need to do to enable that. We need to enable a very wide range of devices, from very small sensors all the way up to complex gateways and very compute-capable, rich end nodes. We need to reduce the time it takes to get those devices connected to a network, connected to the cloud, and contributing their data. And we need to keep them connected and manage those devices throughout their life cycle. We need to make those data streams usable and integrate them into a range of public cloud data services from various public cloud vendors into private clouds or on-premises solutions. And persistent through all of this, and one of the consistent things we hear from enterprise customers we talk to, is the data has to be secure, it has to be trusted. And lots of companies, they are concerned if a device is compromised, if data becomes suspect or they cannot trust that data, you know, how do they then protect themselves and also protect their customers? So I've actually been with ARM, I think 17 years. I keep looking at LinkedIn, you keep getting these congratulations for another year at ARM. And I think it's now 17 years I've been in ARM. And it only feels like a few years ago that I remember we had a party to celebrate the first 1 billion devices shipped by our partners. At the end of last year, we celebrated, since ARM's inception 26 years ago, over 100 billion devices shipped by our partners, a huge number. We estimate the time to the next 100 billion devices is not going to be 26 years, it's going to be more like 4 years. And that is going to be driven by this explosion in the Internet of Things. So ARM Cortex processors and the very broad, 1,000 companies that are in the ARM partnership really serve as a strong foundation for the development of IoT devices. Then to help address the challenge of security across those billions or even 1 trillion devices, we've developed something called PSA, the Platform Security Architecture. And I'll talk a bit more about that later. We've also developed and delivered, and it's running in many products today, an operating system designed specifically for IoT devices called Mbed OS. And again, I'll touch on the reasons we've done that and how we've developed that later on. And lastly, we have Mbed Cloud, which is our cloud product to make it very simple to develop, to deploy, and to manage devices with end-to-end security built in, and running that on your choice of public cloud, private cloud, hybrid cloud, or on-premises solution. So we've been working with many partners today to deploy advanced IoT solutions. I'd like to share with you a brief video by a company called Alphatronics in Europe, where they're talking about how they've used Mbed to meet their customer needs. And it's very quiet.
Known for the solutions we design in the world of access control and parking control management, a French waste collection company reached out to us because they needed a control unit for their bins. They want to prevent their people from going to the units every time something's wrong, especially when there are like 5,000 units in the field. We chose to cooperate with ARM and to integrate the ARM Mbed IoT platform. The module is completely off-grid, so it is powered by a solar panel with a battery. The less power consumption, the better. Also, for security reasons, personal information is communicated from the device to the cloud platform, which has to be secure.
In the search for a company who could deliver or provide us the technology that we were looking for, we found that ARM Mbed, with their solution, could offer us the whole chain of security, from the device to the connectivity itself and the secure cloud platform. Since we have years of experience in writing applications in the field of recycling and waste management, and ARM has the experience in the secure connectivity, this is like a perfect combination to make a great product.
In designing our product, we didn't have to start from scratch. We were able to focus on hardware, and with the ARM Mbed IoT platform, we could really speed up the software integration. Also, with the support we got from the application engineering team, we were able to move from a design concept to an actual product in about 10 months.
Based on the experience we have with ARM Mbed, we see a lot of potential extra features we can add to our existing products
the waste collection unit is just the beginning. We are ready to support the growing smart city, and together with ARM we can offer a product which is reliable and future-proof.
Okay, so I never thought I'd think waste collection was pretty cool, but I do like that video. It's a great company, and it's a great example of the types of companies that we're working with and the types of solutions people are delivering for IoT using Mbed. Last month, you may have seen the news, we announced, KEPCO announced a partnership with us, that they'd chosen ARM to help them with their digital transformation of their smart meters in South Korea. So KEPCO is the largest energy company in South Korea, and they plan to analyze data from 20 million smart meter deployments using Mbed technology. And they're using this to increase efficiency, to deliver better and more secure services to their customers, and to allow data to be analyzed in real time and enable them to optimize energy consumption. But they're also using this to look to the future as well and enable new use cases. So it's a strong partnership that we have with KEPCO, and we hope to deliver on that going forwards over the coming years. And the last example I wanted to talk about is here in Taiwan. And maybe there are some people from Advantech in the room. But Advantech, a local company, I'm sure many of you in the room actually know them. We've been partnering with them for a number of years. They've adopted Mbed for various connectivity platforms to form a secure end-to-end solution from chip to cloud. They also provide gateways based on Mbed Edge to support the millions of legacy non-IP devices that are in the field. And the last thing we've been working with around is also a strategy around modules. So they're part of our Mbed-enabled module program to verify the modules that people can pick up. And again, I'll talk about a little bit more detail about what we're doing there shortly. So these are just a few of the examples of things partners are doing in the IoT space with us. ARM is focused on accelerating IoT in two main ways. Firstly, making it really simple to get devices connected and under management. Secondly, making it simple to access and use data from these devices. So let's start by looking at the devices themselves. So what I'm going to show here is some data from our application enablement team. So we have a team of engineers worldwide in the field working very closely with customers on a day-to-day basis. So one of the things that they've estimated is about 50% of a customer's integration time is actually spent getting an RTOS ported to an MCU, putting security in there, getting the right communication radio protocol stacks up and running, building the file systems, just getting some basic device management in place on those devices. A further 30% is spent actually just connecting that device and getting it under management with the cloud. So provisioning it, doing the update, putting a bootstrap on there, and connecting the data to your cloud analytics, your cloud services. So 80% of the time is spent just doing some basic things before they can even start spending the time on developing their application, which is the thing that enterprise businesses want to be able to go and monetize with. So this is where we've been focusing a lot of our effort with Mbed. And by taking Mbed OS, Mbed Cloud, we can deploy out of the box all of this basic device management and cloud connectivity. And this allows enterprises to really spend their time and focus on differentiation. So what is the operating system Mbed OS? So it is an open source platform. It is free. It is available on GitHub. About 50% of embeddOS is contributed by our semiconductor and OEM partners. It's designed for IoT from the ground up. It's designed to reduce complexity and make it really simple to deploy devices in the field. It includes integrated security and out-of-the-box support for the platform security architecture, PSA. It includes connectivity stacks, so a whole range of protocol stacks from Bluetooth and NFC to LoRaWAN, Thread, NB-IoT, cellular Cat-M1, and Wi-SUN as well, multiple connectivity stacks out of the box you can deploy and get going in 5 minutes with. We've got about 120 platforms, and we have over 320,000 developers for the operating system itself. And this is just an example of a comparison with some of the things typically a developer might have to go through if they're working with just a traditional real-time operating system or RTOS. So they would get the kernel, they get timers, they would get some power controllers, they get some peripheral drivers from the semiconductor vendor. They would then have to source the connectivity, the transport, TLS connectivity for secure transport. They'd have to source crypto of some sort to store keys and secure data. They maybe need some sort of file system they'd have to develop or source one of those. They'd have to go and source protocol stacks, the right protocol stack for their end customers' use. And the cloud libraries as well. They'd have to get the right cloud SDK and integrate that in as well. And in this is an example for asset tracking, where all of these things are just available out of the box with embeddOS. So again, allowing developers, allowing you to focus on the things that are actually going to monetize your business, which is the application and actually your cloud service application. Okay, so new customers adopting IoT typically have neither the time or the engineering resource to develop hardware platforms with a CPU, a modem for connectivity, the security and other peripheral pieces that you might need. And this is one of the areas that we see module vendors actually filling a gap in the market by packaging small microcontrollers with a radio and making it really easy for customers to deploy IoT products very fast and at scale. There are many, many module vendors out there in the world, and actually choosing a vendor and a trusted vendor with the experience and scale to support an enterprise customer requirements for multiple device types, different memory sizes, multiple connectivity options, but having a common developer interface across all of these different device types, that's quite a big challenge. So this is one of the things we've been focused on over the past 6 to 12 months. We recently announced a program that extends the existing Mbed-enabled program, which is all built around MCUs and products with a CPU, to really extend that to actual modules themselves. So it gives product developers a place where they can find production quality modules running embeddOS with a very broad range of protocol stacks. And at the end of the day, this is all about speeding development from prototype all the way to production. Okay, so once you have a device deployed, how do we enable businesses to effectively use the data that it is creating? And we see a couple of really big gaps across different industry verticals. So some companies want to leverage cloud-based solutions, but we also see many more businesses who have no intention of migrating their existing data legacy systems into the cloud. Instead, they require on-premises solutions. So they want to keep their data, their digital assets, behind their business firewall. In addition, many existing IoT systems don't talk together. What we see is, maybe a flow meter will have a flow meter cloud connected to it. Some machinery or machinery control might have its own machinery cloud by the machinery vendor, and so it goes on. You have these very vertical cloud solutions per product. But customers are demanding from us a more horizontal approach to eliminate these technical challenges. So we've already talked a little bit about Mbed Cloud, which simplifies device management of IoT devices with connectivity, provisioning, and firmware update to manage the life cycle of a device. Mbed Edge expands Mbed Cloud's device management capabilities to onboard, control, and manage devices using IoT gateways. And I think it's this flexibility in how devices tie back to end systems that really helps companies derive value from their data more quickly. So as I mentioned before, many companies favor an on-premise deployment over a cloud deployment today. And they do this for a number of reasons. It perhaps provides improved visibility and control for access to data. It could be regulatory reasons. It could be they want to keep valuable data behind the company firewall. Or it could be they want to better integrate with legacy systems they already have. Arm's enabling companies that need these closed, managed networks to capture data and keep their digital assets within their business. So we allow them to drive operational efficiencies and adopt analytics and capture insight from the data that can transform even the most traditional of industries. So our goal is to make it simple to get devices connected under management, and make it simple to access and use the data from these devices. And to do this, while enabling flexibility, choice, and differentiation of solutions. So we enable support for any device, from simple sensors connected to a gateway to much more complex smart device nodes. We have Mbed OS to pre-integrate device management. However, if your choice is to use a different OS for device management, that's okay. We have an SDK that you can port Mbed Cloud device management to any operating system. Mbed OS simply integrates that so you can be up and running within 5 minutes. And our device management cloud, similarly, can work with data infrastructure from other clouds. So, and those, it's down to the end customer to choose which cloud, which data infrastructure they want to use, whether that's public cloud, private cloud, hybrid cloud, or an on-premise solution. So I mentioned security, and security is one of the key concerns businesses have for deploying IoT. I think Arm and the entire industry are focused on making secure solutions. An example would be utilities. So if you look at water, something like that, you might have thousands of miles of pipeline carrying water. And getting data from all of that system could provide some really valuable insights into where leaks might be happening, and you could get significant efficiency savings there. However, if somebody hacked into that system and that water system, that could have quite devastating consequences. So we see trust will be a key element in creating a future where we have 1 trillion connected devices. Industries need to be able to trust their business-critical services are protected. And if you think about the scale of 1 trillion devices and 1 trillion IoT deployments, that creates multiple challenges. For example, particularly around security, for example, the crypto solution for an autonomous vehicle will be very, very different from the crypto solution for a light. It's not appropriate to have the same sort of security solution. Both systems need to be protected, but they have very different requirements, very different constraints, be that physical, be that electrical, legal constraints, or financial constraints in terms of cost. So that's why last year, I think in about October, we introduced PSA, the Platform Security Architecture. This is a recipe for security to allow security to be consistently designed in to products at both a hardware and a firmware level. It establishes a strong foundation for a range of devices with very differing security needs. So we protect against differing threat models. Good example, in the past, you've maybe read about smart meters being hacked and resulting in theft of electricity. So with PSA, secure identity is actually built into the hardware and firmware, so protecting smart meters from that type of attack. Default passwords can be very easily left in a device, particularly an IoT device. And again, ARM PSA uses certificate-based authentication to protect against those sorts of vulnerabilities. So PSA is a broad industry initiative. It's not something that ARM alone can do. It's not something that any single company can do on its own. And this is why we're inviting companies to come and talk to us and really help us evolve industry best practice, and industry best practice in multiple different vertical markets. So please come and talk to us about how we can collaborate on that. So as I said at the beginning, we're at the cusp of a new industrial revolution. And I think the challenge we all face and the opportunity is for us to accelerate that revolution. Make IoT the catalyst that ignites the transformation of industries and creates new business models driven by data. So to achieve this, we need diverse and secure solutions that really move business from thinking about IoT to actually reaping the value from new data streams as efficiently as possible. So this is our focus at ARM. We want to accelerate IoT by leveraging the experience built on over 100 billion ARM processors shipped by a huge number of partners that we have to date. A big part of this effort will be with our partners. It's not something we can do alone. So we invite you to come and join us as 1 trillion connected, secure devices change the world of business. Okay, thank you, and xie.
Thank you very much, Mr. Porthouse. You may now return to your seat. We thank you so much for your excellent presentation. The next speaker will be Joe Jensen, Vice President of the IoT Group and General Manager of the Retail Solutions Division at Intel. Mr. Jensen joined the company in 1984 as a product engineer. He now leads the team responsible for helping third-party brands and retailers use Intel's technology to better serve consumers. Today, he will talk about retail and e-commerce innovation. Without further ado, ladies and gentlemen, please help me welcome Mr. Jensen.
Good afternoon. Thanks for taking the time this afternoon to come and hear a bit about the opportunity we face with the Internet of Things. I manage the retail solutions business at Intel, which is part of the Internet of Things group. And I have to say that in my 34 years in high tech, the opportunity we face today with Internet of Things is by far the most exciting and largest opportunity I've ever seen. So today I'm going to talk a little bit about the changes that we're seeing in terms of how this is going to unfold and how the analysts have studied the market and the trends that we see in terms of transitioning from kind of billions of little tiny simple things like Fitbits and thermostats to really business use cases and how unleashing data at the edge is going to drive tremendous business value. So as I said, the analyst initially talked about Internet of Things as these billions of little things spewing data to the cloud and all connecting kind of directly up to the cloud. And it's clear now that for the business use cases, the data is a lot heavier and a lot larger than initially anticipated. If video is going to be a critical workload, we're seeing a 700% increase in traffic on the network for these commercial business use cases. Prediction is over 50% of IoT systems will be network limited or bandwidth limited, so you can't just stream all this video and all this raw data to the cloud. And we also are seeing that we're going to have to start processing almost half of this information at the edge. So if you think about it, if you have a use case, say you've got a security camera pointed at an aisle in a store and you're looking for certain use cases of product theft, you don't want to stream all the video of this empty aisle 24 hours a day, 7 days a week up to the cloud. It's much more efficient and cost effective to analyze that live video feed at the edge and wait until something comes into frame that's unusual. And then maybe process that a bit at the edge to determine, is it a person, what's happening, and if it's something really important and relevant, then stream it up to the cloud. And so what we're going to start seeing is a lot more of this processing the raw data at the edge. And one way to think of this is you could think of edge processing as the spam filter for the cloud. So we see really three big opportunities for our ecosystem and our partners with the Internet of Things. First, tremendous explosion in the use of vision and video analytics and artificial intelligence and that whole family of technologies. If you think about it, no business is saying, I need more data. Very few businesses are saying, I need more raw data. What businesses need are insights. What is the data telling me? What can I learn from this data that I can collect at the edge? Nobody wants to spend money to just get the data. They want to spend money to get data and learn something from that data to improve their business. And so a lot of this insight, we believe, is going to be really driven by vision systems and the insights that you can get and the analytics that you can run off of vision systems. That also drives a requirement to have a lot more compute at the edge. And we think that instead of having a lot of separate systems working on these workloads independently in a lot of different gateways and compute platforms, we're going to start to see those platforms kind of consolidate into a common system architecture and really enable a lot easier and more simplistic management of those assets at the edge. And lastly, just in general in compute at the edge, whether you're talking about a really simple use case like facial recognition that maybe needs a little low level of compute and some simple video analytics, all the way up to some use cases in retail where we see hundreds or even thousands of cameras in each store. And in those kind of use cases, there's a tremendous amount of workload and a lot of coordination of assets required to deliver those insights that are going to drive business value. So if we look at video a little bit deeper, it's really, I think, by far the most important data type that we're going to see in this business insights marketplace. If you look at it, vision systems are how humans operate. If you imagine working in a factory, if you're working in a retail store, the most important data type that you have as a person is your eyesight. You see customers, you see product, you could recognize a regular customer, you can actually look at a new shopper that you don't know, and you can discern a few things about them by looking at them. And so being able to enable that vision insight and those vision data types into artificial intelligence systems are how we're going to really feed those decision-making engines. Being able to learn from this video, and I think the big evolution that we've seen is really shifting from traditional computer vision into the deep learning approach to understanding video. And it's really unleashed a whole new level of efficiency and effectiveness. And so if you take an example a little bit deeper, imagine for a minute that you own your own retail shop. So you have one store, you're the owner, and because you're the owner, you probably work there all the time that the store is open. Customers walk in, you see a regular customer, you recognize them, you remember the kind of things they purchased in the past, you know what they like and don't like, you go over and recommend to them some things that they should buy. A new shopper walks in, say I walk in, I've never been in your shop before, you don't know me, but you're going to come over, you'll greet me, you'll look at me, you'll make some assumptions based on how I'm dressed, how old I am, I'm a male. What might the shopper be interested in? What do I have that they could be interested in? Say that you bought too many raincoats and it was a dry winter. And so now you have too many raincoats at the end of the season. If you have a raincoat in my size, you're going to subtly pitch to me why I should buy a raincoat. It turns out that in real world data, and we have data across 3,000 health food stores, the very best single shop owners do twice the sales per square foot of the very best 5-store chains. Now, how can that be? Well, it turns out that shopkeeper that has their own store, and it's only one store, they know their customers really well. They know their inventory very well. It's their money on the shelf. They're very careful. As soon as they spread their expertise across 5 stores, they no longer have all the data. They no longer interact with all the customers. They're 1/5 of the time in each store. And so they lose that ability to be the amazing AI engine for retail. And what we're really pursuing at Intel is how do we enable the compute platforms, the sensor data input, helping retailers understand inventory, helping them understand their shoppers and their patterns. How do we enable that so that the AI engine can help drive the same kind of effectiveness that a single shopkeeper can do when they run a store very well? Next, we're going to shift and show you a little bit of what Hikvision is doing with video.
Artificial intelligence technology is transformational and has started to be adopted and deployed into the real world in many different industries. Hikvision, the world's leading surveillance company and the leader of IP cameras, has accumulated more than 10 years deep experience in image processing, data storage, video analytics algorithms, cloud computing, big data technology, and now artificial intelligence. This background has enabled Hikvision to start deploying video AI technology into smart manufacturing. One of the driving forces behind smart manufacturing is smart vision. Enabled by Intel's high-performance and stable architecture, Hikvision's machine vision camera combines perfect image processing and high-speed algorithm execution to deliver fast, accurate information acquisition and identification to manufacturing processes. In the sorting process, Hikvision's industrial machine vision camera reads the barcode rapidly and logs the volume and weight information. It intelligently automates the sorting processing with a throughput of 20,000 orders of parcel per hour, therefore reducing the labor cost by 80%. In addition to smart vision, the Edge Intelligent System is the brain that keeps everything moving with fluidity, precision, and control. The Vision Master platform runs the deep learning-based algorithm from multiple sources of video input. And through coordination with various production management systems, it enables a more autonomous manufacturing process. This includes product line monitoring, sorting, and warehousing. For example, it determines in real time the task assignment for the carrying robot fleet and sends the optimized navigation route for robots to effectively move products to their corresponding location. The result is a seamless, efficient, and integrated system.
So that's an example you'd see from an intelligent factory around logistics. Examples really play out across all the market sectors. Smart cities, cameras will be incredibly important to understand traffic patterns, parking patterns, patterns of human traffic, and how to best optimize and make your city efficient and effective. We showed the example of smart factories and video cameras around logistics. You'll see video camera systems for spotting defects, for optimizing the flow of product through the manufacturing line. Really, in any instance where a human could use their vision to drive effectiveness and efficiency, we'll see the ability to bring computer vision to bear. Autonomous cars, you're going to have a vision system for a car to be able to see the world to drive. And then lastly, in retail, we think you're going to see vision in many, many use cases. You look into retail, we talked about the example of seeing shoppers. You need vision systems to understand product inventory, vision systems to understand potential traffic coming through the mall or looking at the parking lot to see when the queue is going to start to get expand for the restaurant. And if you look at the size of this video opportunity, it's really staggering. By 2022, the forecast is for $11 billion of video analytics systems, really driven primarily by surveillance and security. Additional use cases, and the kind of examples I've been talking about, will drive that market to $17 billion a year by 23. Deep learning as a key AI technology to process that video is expected to be broadly utilized in video and other use cases, and deep learning is going to grow from over $600 million in 2016 to over $35 billion by 2025. These are a massive opportunity for us all as an industry, and if you look at it, in large part, this is greenfield. This is new market creation, new opportunity for all of us to go after. But as we look at the challenges of trying to deploy this and the amount of technology you're going to deploy, take my core expertise in retail, it's very challenging for a retail store to be able to lay in all this technology. Historical retail is a human-to-human business. It's personal, it's human interface skills. There's not a lot of technology underlying that experience. And we're seeing a really big rush and movement towards moving more of that into the store. But how is the store going to handle that? If you look at an example in retail, and you want to bring in, say, in a fast food restaurant like McDonald's, we know that they want to use technologies like RFID to make sure they can ensure that their inventory is fresh, and their inventory that they never run out of French fries or never run out of product. They're using cameras to track traffic in the parking lot to predict when they need to have more product ready and hot for the customer for quick service. They're using cameras to check the checkout queue to see if the customer line is getting too long. They have cameras at the drive-thru to understand what the traffic pattern is in the drive-thru. They have cameras at the menu boards to look at what the shoppers are ordering and to understand patterns from different shopper demographics into the store and how to better promote their products. You could easily see that they could end up with 5, 6, 7 different individual isolated platforms with their own gateway, with their own camera system, their own data processing. That's not an environment that's very friendly for scale. You end up with way too many platforms, too many suppliers, too much uniqueness, and the data can't be shared between those platforms easily. And so we think you're going to see workload consolidation happen at the edge, where these new compute workloads will land on a common processing platform. Data, like the camera data, will be ingested into the platform, and you can have that data that's ingested be available to multiple application vendors. And so you can install cameras once, ingest that data, and then all those use cases can take advantage of that camera data. So if we look at the kind of compute challenges we have, there's a huge breadth of processing required. As I mentioned earlier, simple use case like facial recognition, very low compute requirement. That'll be a low-end CPU, maybe with some optimized scoring engine or deep learning capability at the edge. That'll scale all the way up into some use cases where you may have hundreds of cameras. How do we as an industry enable the ecosystem to take advantage of those various workloads? And you got to deliver the right breadth of silicon product capability. So the challenge for this, of course, is you've got to be able to have a breadth of compute capability. You can't just deliver the performance to handle the high-performance workloads. There'll be too much cost and too much power. And for the application developer community, for building these video analytics applications, you don't want to have to write a dozen different versions of an application. If you're looking at object detection, in the case of autonomous retail store, how do you enable that ecosystem to write that application once and land it across a wide breadth of compute capabilities? that was actually an example of vision systems being deployed by Walmart through a company, Bossa Nova. Bossa Nova's developed a robot system that employs 14 high-def video cameras and RFID sensors, and the robot goes up and down the aisles during the day as the shoppers are in the store, analyzing the shelf inventory to make sure that the Walmart can have 100% on-stock availability on the shelf for their shoppers. Bossa Nova deployed in 50 Walmarts last year, and they're scaling up to hundreds of Walmarts this year within a plan by Walmart to scale across the entire chain. So one of the challenges is a breadth of silicon roadmap. Another challenge is an application development environment that's going to enable these developers to develop across this wide breadth of performance and capability. At the show here, we've announced the OpenVINO toolkit, and it's a development environment that enables application developers for these video workloads to write their application once, to write their algorithm once, and then we can port through the toolkit to any combination of Intel acceleration and compute capability. So it could be an Atom processor with Movidius accelerators. You could have a GPU. You could add FPGA. Scale all the way up to Xeon plus acceleration. It's really critical. So you can have a customer like JD, and we'll look at their video in a moment. But you can have a customer like JD.com, where they're going to write algorithms for object detection, for customer detection, for heat mapping. And they can actually write those algorithms once, and then they can land them on any level of compute. So for a small store, they can have a small level of compute and run those algos. And as they scale to a much larger environment, they can actually run the same algos on through the same toolkit on a different level of hardware platform. So autonomous retail is another interesting trend. We saw Amazon announce the Go Store in 2016. That really shook up the industry. JD.com is one of the players we're working with who's very aggressively going after this autonomous retail.
未来的零售会是怎样的体验？京东便利店来告诉你答案，它能热情地响应你的光临，智能地响应你的喜好，及时地响应你的选择。 便捷地响应你的支付，并期待着响应你下一次的光顾。它还能响应店主在理货和库存管理上的需求，还有他们对顾客购物习惯和偏好的强烈好奇心。 能同时响应这么多需求，它的秘诀在于采用了先进的智能物联网设备，并且在系统中应用到英特尔架构的边缘计算节点。边缘计算节点堪称京东便利店的大脑，它借助人工智能的软件加速，能将所有物联网设备采集的数据进行融合和分析，让顾客和店主同时享受到顺畅、高效、贴心 和智能的响应式零售体验。
京东便利店是我们面向第4次零售革命的一次重要实践，它让我们看到了驾驭数据力量、创造零售商机的无限可能。Intel 为我们提供了性能出众、易于维护的边缘计算节点，并充分优化了我们的人脸识别和商品识别算法。在 Intel 平台上的性能，我们将以此为基础，与 Intel 围绕其响应式零售平台开展深度合作，希望能为整个零售行业的数字化和智能化变革提供更多的助力。
Examples of how technology is going to be really critical to reshape the future. And what we're actually seeing in the retail industry is tremendous disruption. If you look in retail, we have old school retailers, brands that we all know and have loved for a long time, and they approach retail very traditionally. It's a people business. It's all about the human interaction, and in general, they don't really utilize data well, and they're not prioritizing. We don't believe as much as they should how important insights and analytics and data can be to their business. And there's a new breed of retailers. The new breed of retailers we call digital natives. The digital native retailers are companies like JD.com, Amazon, Alibaba, companies who have started their brand branded products with an online-only presence, or we're now expanding into physical stores. These digital native retailers don't need to be convinced on how to use data. They know they need the data. They know they need data to run their business, and they need the analytics. They come to us not asking, why do I need data? They come to us asking, how do I get all the data? How do I get the insights I need to run my business effectively? And what we really believe are these digital native retailers understand the future of retail. They will be the winners in this disruption we face in retail. So if we take a look at kind of what's next in retail, I remember the first time I saw a video or a commercial, I think it was for Pizza Hut during the Super Bowl. And it was showing Pizza Hut delivering pizzas via drones. And I thought, how absurd. There's no way you're going to see drones delivering products. How could that ever be cost effective? Yet here we are today, and we see all the major online companies experimenting, live experiments, actually delivering product via drone. In the case of JD.com, they're going to use drones to enable delivery to remote villages where it might take an hour to an hour and a half for a truck to get to a village. They can fly a drone in 5 minutes up over a mountain ridge and deliver product. Drones that can deliver 10, 20, 30 kilograms worth of product. Really amazing. Because if you think about that, and you think about the capabilities of AI, the capabilities of autonomous things and vehicles, what else is going to be enabled with AI? If we take another quick look, we've got a customer partner who's building a new vending machine which has no mechanicals in it at all. It's an intelligent refrigerator. It has facial recognition to give you access, so it recognizes you to let you in. You open the door. Whatever you take out, it detects the object that you've taken out, it adds it to your account, and when you close the door, it gives you a total, and you click, yes, I want to purchase, and you're done. Economics, that new computerized, AI-driven vending machine is half the cost to manufacture of a traditional mechanical vending machine. AI is in its infancy. Computer vision is in its infancy. If we're already able to build a vending machine at half the cost of traditional vending, where are we going to be in 5 years with AI and computer vision technologies? We're at the cusp of what this industry can deliver. This audience, you're the people who are going to be able to develop and deploy and scale these exciting new solutions. And so shifting gears a bit, I want to talk a little bit about how we're enabling the industry. We've got a long history of working with the ecosystem to drive scale and bring these new technologies to bear. And a new approach for Intel that we're adding is really two-faced. The first one we're calling the RFP-ready kits. And what we've realized is the solution integrators, the experts in each of these vertical industries that know exactly the business problem that needs to be solved, they're not aware of the breadth of capability our ecosystem can deliver. And so the RFP-ready kits are a way for us to bring the solutions from our partners along with the ISVs and a complete deployment example to put it into the ecosystem to show them how these solutions can be delivered. And these RFP-ready kits are a great starting point for these solution integrators to go pick the elements they need to deliver on the real use cases for each business sector. We have 20 of these already today, and we're adding 10 or more is the goal per quarter indefinitely. And there's really no limit or cap. We want to be able to showcase as much of the technology that our ecosystem can bring to bear as possible through these RFP-ready kits. The second piece is as we go directly to end users. And so the first piece is really aimed at those solution integrators. The second piece is actually aimed at end users directly. End users meaning, for example, a retailer in my case. The market-ready solutions are ones that you can show to a retailer or show to an end user in industrial or energy or any other market and say, here's an exact implementation, here's the ROI for that implementation, here are the partners that were a part of that solution, and here's how you can copy that exact solution exactly and bring it into your environment. These market-ready solutions are proving to be very successful as well as in terms of being able to show end users how analytics, how AI, and how this data can really transform their business. And it takes away one of the big barriers that we see where customers are they're kind of intrigued. They don't really know if this is going to work for them. They don't really have a good roadmap or a blueprint to show them how to get it done. This gives them that really clear, simple way to get it done. And so we have those today, and you can see that We are focused in retail, industrial, and then we've got a bunch of other markets, healthcare, asset tracking, all kinds of other markets in the broad market space. And so I think the call to action for all of us is huge opportunity. As I said, the biggest opportunity I've seen in my 35 years in technology. The right technologies to deliver. We've got a breadth of performance, a range of performance that's really unmatched by anybody, and coupling that with CV SDK, or this OpenVINO development toolkit, will enable you to build a range of performance and build an application developer community can land on any level of performance. And then lastly, we're bringing a new element to our ecosystem enabling, which is bringing these RFP-ready kits and the market-ready solutions to the end users and to the solution integrators who are going to drive scale for everybody's platforms. And I'd like to thank you for your time.
Thank you, Mr. Joe Jensen, for joining us this afternoon. And ladies and gentlemen, the next keynote speaker will be Sam Fuller, Head of System Solutions for NXP's Digital Networking Group. Mr. Fuller has over 20 years of executive leadership experience in computer architecture, SoC architecture, embedded systems, and semiconductor marketing and applications, and has led innovative development efforts in SIMD processing, fabric interconnects, and symmetric multi-core processing. So without further ado, ladies and gentlemen, let us put our hands together and give a very warm welcome to Sam Fuller.
I'm very happy to be here in Taipei to speak with you. One of the reasons is that Taiwan is very important to me. My mother is from Taiwan, and I used to come here summers, and I would spend summers in Taiwan. So when you might see me out in the early morning going and finding a little corner shop to get some xiaobing youtiao and or xiaolongbao for breakfast. You can never find that in America. There's lots of Chinese food, but never Chinese breakfast in the US, and it's the only place you can get it here. So I'm here to talk about the ubiquitous intelligence, the IoT, and something we call secure edge computing. The previous speaker talked about edge computing. We think this is a big thing. It's important. The cloud is something that everybody thinks about now. It's growing tremendously. It's really sucking a lot of the compute resources that have been in traditional enterprise data centers, on people's laptops, in our computers, sucking that into kind of these very efficient hyperscale type systems. But when that's happening, it's also creating kind of a vacuum. And as we build the Internet of Things, we're recognizing that we need to have computing closer to the devices, to these trillions, well, I'll talk about tens of billions, but trillions of devices that we're all deploying in our homes, in our cars, in our businesses, in our factories. As we deploy those devices, we need to have computation there. And it's a new kind of computation. It's different than what we've used before, because this computation is not, it's not managed by people, right? We're not turning it on, we're not typing into it, we're not interacting with it directly, it's just kind of happening. And that creates some interesting new challenges and opportunities. The security aspect is paramount there. So I represent NXP Semiconductors. NXP Semiconductors is, our tagline has been for many years, secure connections for a smarter world. We work to ensure the security of devices, of information, of data, and we do that with various microcontrollers and microprocessor products that are, I think everybody interacts with our semiconductor devices no matter what you do in your life. We are the 7th largest semiconductor company in the industry today. We're headquartered in the Netherlands, about 30,000 employees. Of a little over a third of those are engineers. I count myself in those ranks. And about 10 billion years, about a little over $9 billion a year in revenue. We are the #1 provider of semiconductors into automotive, #1 provider of broad-based microcontrollers, secure ID solutions. A lot of the NFC in your phone or in your wallets or other things are provided by NXP. We also provide communication processors that drive our connected world, as well as the RF transceivers that make the wireless communication possible. So, you know, there's a significant opportunity ahead, and it's going to be quite huge. As the world really becomes connected and every device is connected, we have this opportunity where the nodes of the network have the benefit of learning from every other node in the network without having to be directly connected. So that's, you know, we experience it ourselves, right? When we carry around our phones, can search anything and look on stuff. But now we're talking about our machines being able to have kind of a similar level of connectivity and awareness of what's around them. If we think about it in terms of a traditional network orthodoxy, the collective value of a network is proportional to the square of the connected nodes, right? And as the internet was being developed, people started to realize, wow, this is really powerful. I mean, it's one thing to have a local area network and you connect some computers and a printer and stuff together, and that was more useful than a single computer. And then we started to connect all of those up into the internet, and that became even more useful. And now we're talking about networks that could have billions of units. And we'll see if this plays through, but you know, we know our homes, our cars, our factories, our own health, our bodies, things like stadiums and other things create tremendous opportunities for developers of technology to create new things. I mean, I spent most of my career working in computing, like personal computing and other things, and you know, those aren't so hot anymore. And now it's kind of phones and clouds, right? So, but the innovation of those devices is starting to slow. Not that they're not useful; they're very useful. But now, as we look to take this tremendous gift that we have of software, semiconductor technology, communication technology, and create a connected world that will have, you know, at least 3x, if not 20x, the number of devices per people, you know, that creates some problems. And as technologists, we like to solve problems. So when we think about this world, we'll talk about everything being smart, and we'll talk about smart and what that means. We'll talk about connectivity, because everything is connected and what that means, and we'll talk about security. And I'll just kind of go through those in that order, and hopefully you'll understand why we have such passion for the things we do. All right, so let's talk about what it means to be smart from a technical perspective. I started my career many years ago actually in mainframe computers. And I worked for Amdahl Corporation in Sunnyvale, California. And Amdahl made a mainframe computer that, I remember this was so awesome to me. This machine had four processor cores in it, and they ran 100 megahertz each. And it was a $20 million machine. Okay? That level of performance I can get for about $1 right now. Right? That's what we've done in terms of processing and semiconductor technology. And now what we have are these data centers that are billions, if not trillions of times more powerful. We say they're in the cloud. Actually, they're in, you know, big buildings. But they're connected to the world through fiber optic networks, and they're connected to all of our, to our homes, to our phones, to the industry and other things. And this is, I guess, about one of the only commercials I'll make is that we provide a variety of various product lines. LPC and Kinetis are microcontroller product lines that we sell. Those are typically sell for $1 or $2, maybe $3 or $4 if you don't buy very many of them. But those are the things that are in your thermostat. They're in the door, in your car doors that open and close your windows, steer your headlights, those kinds of things. Those are microcontrollers. We sell microprocessors in the kind of Layerscape, S32, and i.MX lines. Those are really microprocessors. They're in tablets. They're in the, in automobiles. These cars are now coming with really cool infotainment and e-cockpit things that drive, lots of graphics and lots of information on demand in your vehicle. A lot of that's driven by i.MX. Layerscape, the processors are really focused on infrastructure, processing and computing and communications infrastructure, and S32 devices are really what drives the motor in the engine in your vehicle. So those are things you may not have heard those names before, because we kind of are embedded in the fabric of your life, but those are various product lines that we sell. And so these devices that we make are now becoming connected to these new big cloud services. And those cloud services really connect the world and provide information to all of us. So we've built that network now. All of that stuff's there, and we're at the midst of another sea change in technology, and that's AI. AI, I like the term machine learning a little bit better, but we often in our work we're AI/ML because we want to kind of capture both aspects of it. But when we look at this, Sundar Pichai, CEO of Google, and I don't think he was overstating it. He says probably the most important thing humanity has ever worked on, as profound as electricity or fire, which are pretty profound technologies that we found very useful. And this new technology, I think, will really change everything for the next 50 years. It's certainly going to change how we develop processing devices. It'll change the way we write software. And it's going to produce a lot more intelligence, artificial or otherwise, a lot more intelligence in the devices that we sell. Now, NXP is typically not thought of as an AI provider, but a recent report from Compass Intelligence listed us third because they recognized, and I think number one was NVIDIA, number two was Intel. Intel's obviously made a lot of investments in this space as well. You got NXP, you got IBM, AMD. NXP was third because there's this recognition that AI is not just about big machines. It's not just about leveraging GPUs in the cloud or in a very, very big, $1,000 or multi-$1,000 box. AI has to be at the cost level that we can afford it as consumers, right? So if you buy something for $100, it's a piece of electronics. It's probably only got $4 or $5 worth of processing silicon in it, right? There's lots of plastic, there's lots of retail markup and things like that. So when you look at kind of what you want, what you're willing to spend on something, the capabilities to integrate that in a device at the semiconductor level, we have to be able to make that inexpensive to be able to sell it broadly to consumers. And that's what NXP is doing. We're really working to make AI technology available for the myriad of little devices that we use in our homes and in our cars and in our life. So this diagram is intended to kind of show, there are different levels of complexity You know, we talked about like face recognition. Yeah, it's a relatively simple problem. You can solve that problem with a relatively small processor. We solve it with, you know, in fact, I know people that are solving it with, you know, $3 or $4 worth of processing technology. If you look at, you know, if you're trying to classify something, you've got data you want to classify, and you've got, you know, just a handful of things you want to classify with, you can do that very easily with a low-cost microcontroller. If you have a little more complexity, things like, you know, traffic sign recognition, you know, some of these cars have got cameras that will see, you know, what's the traffic sign? Is it a stop sign? Is it a yield sign? What's the speed limit? You can read those things. That's a medium complexity kind of problem. Takes about 1 billion operations to do those kind of problems, but in a gigahertz processor, that's like a second, right? It doesn't take that long. And then there are very high complexity type applications that, you know, where you're building something that really feels very intelligent, right? Show it any picture, random picture, and it tells you what's in the picture, or it understands your language. Those kinds of things, they're bigger now. I think they will, over time, we're going to be able to shrink those down. We're going to be able to deploy them in smaller and smaller form factors. And especially with the connectivity to the cloud, we'll be able to build some really, really interesting systems. But if there's something you can take away, it's that there's, you know, yeah, there's big iron out there, but there's going to also be a lot of little iron solving a lot of problems. And that's something that if you're, you know, if you're someone that makes consumer goods, you need to understand that and understand how can I incorporate this technology in something that I sell. Okay. Now, when we think about that big cloud, the big cloud computing infrastructure way up there, one thing we got to recognize is that to a human being, it's pretty close, right? When we search something, it feels responsive, right? You know, I type in some stuff, I say go, and I get a response back in under a second. Usually it could be a quarter second, you know, if things are working well. But a quarter second is can be an eternity when you're the scale of you know, of a microprocessor, right? We just recently introduced a new processor that could execute 153 billion operations in a quarter second, right? You can do a lot of work in a quarter second, do a lot of processing. And a lot of people are starting to come to grips with this concept of, well, if, even though I've got a huge computational service in the cloud, I have to pay to access it because the bandwidth to the cloud is not free. I have to pay for that. And then I have to pay for the compute cycles in the cloud. I may want to do that, you know, and they can be very efficient. But there are some economics associated with trying to do everything in the cloud that you need to be aware of, and they may impact your decisions. And you can actually get quite a lot done locally if you structure your silicon and your software correctly. Okay, so now that's about all I wanted to talk about in terms of the smart stuff. Now I'd like to talk about connected. I've got a little bit of a video here. Hope it plays well. But this video shows essentially a demo. It's not as slick as what the Intel guy was saying, but it shows a demo of kind of a connected system and how that works. And it's a face recognition solution that's built on some of our silicon and some other stuff. Now, what this does is first, it's like, let's use a cell phone to capture the image. So you type in the little information, and you use this cell phone app, and it's actually an applet that runs on WeChat, and this guides you through. In fact, if you look on the kind of on the left there, it says, okay, this one, it doesn't have a 3D imager, so it's like, okay, look left, look right, look center, and then once it's captured the face with the information you provided, that automatically goes to the cloud, gets classified and dropped down into access systems that are connected. So these things are not all in the same place. So, there's Guofeng and Shenyu, right? And we can recognize both of those together with the system. Like I said, kind of a simple system. But one of the key things is this was not all done on one computer. This was done on a set of various processors, right? So I did a face capture with cloud connectivity on a consumer device, and I could just download the software in that. And then that went into a cloud little service, a little leased machine in the cloud that was running a training application. So when the data arrives there, runs the application, does a training thing, creates a dimensioning database, that gets loaded down into a gateway, an edge gateway, right? So this is not a traditional computer, it's really kind of a wireless access point, right? So it goes into that gateway, and the gateway is connected up to various sets of cameras, right? And the cameras can run a little bit of CNN, a little CNN on them, so they identify faces. So when they see a face, they just send the face up to the gateway. And the gateway runs a FaceNet algorithm that does a FaceNet and then a face classify. And once it's done that, it takes the image that the camera sent and then can send that to a separate UI system to display it. So that's done. It's kind of like a web browser interface. But so this is a very distributed system, right? It's not one box, it's not one thing that does face recognition. It's a bit of a gateway software, it's device software, and so we created this capability out of essentially things that already exist. It's really about how do you structure the software and how do you build a system that's cost effective in the role that it's doing. And this is really the heart of connectivity. It's recognizing that with the connections and the networks that we have today, I can move processing to where it makes the most sense to be. I don't have to do it right, you know, I don't necessarily have to do it where I would think I was doing it. I can move it economically, maybe to create a lower latency, maybe to create more security. Sometimes, you know, a lot of these things that are happening now, like when people talk about edge processing, one of the reasons they want to do it is that the governments have rules about what data can be moved across state lines or across country borders. And so being able to process personally identifiable information right when you capture it, so what you send away is now anonymized, in a sense, is another reason to do this stuff locally. Okay, so now we'll talk about security, and then we'll try to bring this all together. So security is multifaceted. There's, you know, I mean, some people will talk about it as like passwords and, you know, choose a better password. When we talk about, pick a number, 20, 30, 40 billion connected devices, I promise you they don't have a user ID and password, okay? So, you know, these devices, when we interact with them, we'll maybe need a user ID and password. When they talk to each other, they better not be logging into each other's systems with some user ID password combination. You got to move beyond that. You got to move to secret storage, right? Keys, secret keys and certificates. Well, the problem with keys and certificates, which are better than passwords, is that people will still break into the system. Maybe they have physical access or other things. People do things like they'll like freeze the DRAM, freeze the memory, and take it out, and then stick it in another system and then read it out to see what was in it, right? So they'll like freeze it up so that the data won't come out of it, and they'll take it out and put it in another system. There's all kinds of tricks that people play to try to break systems and get at the secrets that are in those systems. So NXP has spent decades developing semiconductor technology that is more secure, and that is not only secure against cyber attacks, but also secure against physical attacks. So when we store secrets in our device, it's never in the main memory of the processor. It gets loaded away. In fact, you know, it can be cryptographically implanted or put in at manufacture. But that, what we call the hardware root of trust and secure storage, means that typically the way we talk about it is that you can use the secret, like you can use the key to unlock the data, but the key is never visible to software. Essentially, you talk to a piece of hardware, and you say, hardware, would you please use your hidden key to, to do this? And then you have to give it a token that it trusts to decode, de-encrypt some other information that you want to be able to use or look at. But that concept of, it's kind of like your credit card number, right? You don't write your credit card number on, on the outside of your wallet, or you don't put it in, where it's visible. You have to keep it hidden, and you have to keep it in a place where it's not accessible to someone who would just kind of look for it. So when we talk about security, there's what we believe, you have to have a hardware root of trust. That hardware root of trust means that the hardware itself has got to be built such that it boots the right way, and such that it stores the secrets the right way, and such that it interacts with the firmware, the operating system, and the processor architecture itself. So that's something we've done for well over a decade, and I think we're in the third or fourth generation of deploying technology that's based on that kind of secure boot, hardware root of trust, all of those capabilities. Then you've got to be able to provision. When you load software, you want to check that software before you run it to make sure that nobody has changed it from when it was first developed, when it was deemed good and signed, and say, okay, this is the software that should run on this machine, and here I'm going to calculate a checksum hash, and I'm going to attach it to the end of that, and I want to make sure that when the machine runs it, he checks that and makes sure that nothing has changed. He's going to recheck the software, he's going to check it against the hash. That's really the secure provisioning and updating. And then within the operating system itself, you need to be able to secure runtime system operations. We actually have hardware in our devices that will monitor the kernel, and if any changes are made to that kernel that would be reflected like a malware injection, it'll actually throw an exception, and the machine can depending on, it's kind of this secure firmware control, but you can like force the machine to reboot. You can log it, you can do things like that, but you can actually detect when these things like malware get injected into your system. You also want to make sure that the OS itself is always up to date and it's got the right kind of security features. Application isolation means that within, whether it's virtual machines or containers or processes that are running, that the hardware of the system is able to securely partition those things, not just through software, but also with the assistance of hardware, and secure those. And then as you communicate and as you encrypt data and other things, being able to offload the cryptographic functions is something else that we do, and we do quite well, because cryptographic functions are by definition computationally intensive. They take power, they take time, and if you can move them into hardware that's specialized for the processing of that, you have a more efficient solution. So this, I think, kind of shows, so there's three kinds of technology that NXP offers. One would be secure element devices. So these are like microcontrollers, small devices that you can put in a system, and they securely provide cryptographic operations, secure key storage, hardware root of trust, and protection against attacks that are, physical attacks. Like if you store a secret in this A71CH, you can take the thing apart. You can spend millions of dollars trying to deconstruct it, but you'll never be able to determine what the secret was that was stored in it. Within the microprocessors that we make, we have two technologies. One of them is called high assurance boot. The other is trust architecture. It's a combination of features that ensure, as I mentioned before, that the system securely boots, that the storage is that there's secure storage for keys, certificates, and other things, that they're protected, that actually if you decide that you want to revoke a key, like if some key went bad, you've got mechanisms to revoke it and instantiate a new key. You can debug the device securely. Sometimes people will leave things like the JTAG debug ports or USB ports or stuff that have an ability to get into the machine and look at what's inside of it. So you got to be able to secure the debug. You got to have tamper detection. There's some mechanisms in our devices. So if you tried to take the chip out of the system, essentially it flushes its keys so that it can't be so that the secrets can't be determined. I mentioned the strong partitioning. That's an operating system software capability, and manufacturing protections or mechanisms that we put in place to ensure that we can securely manufacture and install the secure keys and things within a device. And then the last thing, and I'll talk about it some more in just a minute, is this edge scale secure platform. And this is really how you take devices at the edge in the network and you connect them securely to the cloud. And you can do that automatically without human intervention, so that you can scale quickly to, you know, hundreds of thousands, hundreds of thousands of systems, because you've kind of pre-built your system such that it can connect and securely update itself and get its software build and load. We all do this ourselves with our cell phones, right, when they update. And we have to generally participate a little bit in that process. So imagine that process applied to, you know, kind of whatever devices are deployed out at the edge of the network. So let's work to pull this all together. I think it's we'll talk about kind of how this works. So as I mentioned, NXP has the world's largest ARM portfolio. We probably have more ARM-based devices. In fact, we do have more ARM-based devices than any other company. We have a very broad set of scalable compute platforms, from very low-end microcontrollers up to high-end 16-core devices with 100 gigabit Ethernet. And we have leadership security across our products. And then we've got this cloud infrastructure. And the problem that we're working to solve right now is how do we connect those together securely? And what we've hit on is this concept of the edge compute gateway, in which we built a software platform, and it can support kind of multiple operating systems and a layer of middleware, and then an application layer that allows us to run kind of cloud developed or deployed applications at the edge of the network. I think we'll have Amazon here speaking as well, but one of the partners that we've worked with in this technology is AWS. And AWS, as you may be aware, has introduced their Amazon FreeRTOS, which is a kind of a microcontroller operating system that works on our microcontroller devices and is really the foundation for much of the endpoints of the Internet of Things. And then in the cloud, you've got this broad and rich set of functionality in the AWS cloud, for example. We do work with other vendors as well, but I think the AWS cloud is perhaps the best example of how to do this right. But the AWS cloud uses, they have a technology called Lambda, right? So it's this language that they've developed for developing applications. And so they can develop applications in Lambda and they run in the cloud. And now what they can do is they can take those Lambda applications and carve off pieces of them, and they can move them to the edge. So they can take something that was written for running in a cloud infrastructure and take it down to run it on a gateway as an app in a container, in an edge gateway, and then that device can process data that's coming from the endpoints, going to and from the endpoints. You're going to process that data and work collaboratively with that cloud infrastructure to create the next generation of solutions that we're working to create. So that's really how the edge scale works to support this. So edge scale is We have software and a platform that runs on the devices at the edge of the network, these kind of gateway devices. And then it's also a set of services in the cloud. And this next slide provides a little more, I don't know if it's that much clearer, but it's another view of it. We drew this as kind of this 4-quadrant chart. At the bottom left quadrant are the devices themselves, right? And they have a requirement for device provisioning and device management. So I got to be able to load software on it, and then as they're running, I want to be able to manage them. I want to be able to see what their health is and interact with them. And so that functionality, which we provide, it's actually part of our SDK, is a kind of a free deliverable, that interacts with a secure device management service in the cloud. So these products can actually connect to this cloud service. And this cloud service, which is, you have consoles or CLIs to interact with it, then is able to manage the software, the base software that's on the device. So not just the kind of device management software, but also install operating systems, applications, cloud frameworks into a device from the cloud. And then once that's done, then those applications would then interact with whatever application management service. And so that could be Microsoft Azure, it could be AWS. We work with Aliyun in China. We work with Google. And then some companies are like developing their own, right? We see all of these things happening, and we want to have a mechanism and a framework that supports all of those things. So this is the kind of the edge scale technology. It's designed to run initially on our processors. We've had some opportunity to deploy it on other products, and it works there as well, although we're mainly focusing on being able to enable customers to build great systems with the NXP devices. So NXP devices, this is a set, this is just the Layerscape portfolio. I decided not to try to show you everything we do. This is my particular BU. But as I mentioned, there are i.MX, broad set of products. There are Kinetis and LPC as microcontroller product lines as well. So from single core A53 devices up to 16-core A72 devices, we've got a broad set of functionality to meet almost any requirement in edge computing. So yesterday, we announced that we were going to take this edge scale technology and work with partners to embed that within their systems. So with these partner companies, and ARM contributed a quote to the press release, but the other companies, Acton, Delta, Nexcom, Shanao, Amago, and Scalus, have agreed to bundle or pre-integrate the edge scale suite of cloud-based tools on their systems. And that'll make it easier for their customers to be able to start to build these kind of connected systems that this new technology permits. And beyond that, and I think we're about to the very end of my presentation, this builds on top of previous announcements that we made with CMCC on their, this technology is being trialed in their virtual customer premises equipment, VCPE trials that they're doing in China. AWS with the Greengrass integration that we've done with Greengrass integration and our edge scale framework, the Alibaba Cloud partnership, and the Microsoft Azure secure edge computing effort that they're doing there. So it's multiple clouds, it's multiple equipment providers, and it's technology that I hope you'll agree will ensure that we live in a world where everything is smart, connected, and secure. Thank you very much for your attention and time. I appreciate it.
Thank you once again, Mr. Sam Fuller, and welcome back to Taiwan once again. We hope to see you again next year. And the next speaker will be Bruce Bateman, CTO of Smart Life and Applications SBG at LITE-ON. A true expert in innovation, AI, and future technologies, Bruce has been working and researching the field of telecommunication, networking, large Wi-Fi deployment, and IoT for smart and connected cities. So without further ado, I would now like to turn the program over to Bruce Bateman.
Good afternoon. Good afternoon. Afternoon. 哇，很高兴今天下午可以来这边演讲。On behalf of LITE-ON, and unfortunately we have to do it in English, so 没办法。But 今天 sorry. So today you've seen a lot of new technologies and a lot of partners of LITE-ON. People who do chips, who do systems, who do security, who do AI, Amazon, later on Microsoft, people who build this ecosystem that people who would then build devices need to use. And these are, I want to talk about today, is the next part of this ecosystem. How do we go from these components and these beautiful cloud and these beautiful security products, and how do we actually make products? But I kind of want to start at the beginning, and everybody kind of knows this, that we're changing. People are moving into the city now, and cities are getting bigger. And if we don't do it correctly, we're going to create these big, massive poverty areas where we don't have the skills and we don't have the infrastructure prepared for this. So what happens when we do that? What happens now when we build this big cities and we don't prepare, we don't have the infrastructure, and we get the pollution, and we have the pollution, and we create a lot of extra that we really don't want to have. So a lot of people say, well, let's build a smart city. Well, that's very easy to say, but there's a very fundamental difficulties in that. We want to build a smart city, but the problem is we really don't know why we're building it. Why are you doing this? When I go to see smart city governments and integrators and people who want to use our products, I ask them this question first. Why am I here? Why are you building this? Is this a political smart city? All right, in Taiwan we have this sometimes. Right. Where we want to have a smart city so that the government can say we have a smart city, so that our politicians can stand up in front of everybody, cut the ribbons, shake their hands, okay, and do a smart city. Is that what we want? But what happens with that, is that you get a lot of POCs, a lot of proof of concepts, a lot of ideas, but nothing happens. Or we have what we call now a theoretical smart city, which is, I don't know what I want, so we're going to try a whole bunch of things. And we'll see what happens, and we'll see what I like. Well, again, a lot of ideas, long POC cycles, and we really don't know what we're getting. Or we're going to try to solve a problem. Let's pick a problem. I don't care what the problem is. Let's pick a problem, and then we go and try to solve it. These are where you have success. But you have to be able to identify what that problem is and what you're trying to solve. And then there's a new one now, which is called digitization smart city. And you'll see this now in a few countries, in a few cities. They are now digitizing their city. Not so much sensors and cameras and all. They're taking their services. For example, doing building permits or doing taxes, or everything they're doing now is 100% online. You cannot actually visit an office. They're actually putting all the road service, traffic services, infrastructure, what the opera is, everything online, so that you can now have this digitized city. So why are we doing this? What is your objective? So the next problem we have is there are no two cities that are alike. Taipei, Taoyuan, different. Kaohsiung, Tainan, everybody's different. London, Paris. So how do you as an SI, as an integrator, designer, work about? How do you deal with this? Well, the problem is everyone has different objectives. And everyone has different coverage areas. So some of them are small cities, some are huge cities, some are, Shanghai is 24 million people, all of Taiwan in one city. They have different problems than Taipei has. They have different issues that they're trying to cover. They have different budgets. Some are government budgets, are federal. Some of them are only local budgets. So where's the budget coming from? Do they want it from the private companies, or do they want it from the public? What resources? When I say resources, I mean in the government, what resources, what expertise do they have? Are they experts at building smart cities? Most city people are city government officials, and they've been doing this for 10 years. They know how to get paper from A to B. They don't understand that networking, Wi-Fi, and Bluetooth and how all that works. They just think it's all magic. It's not. What are the internal skills of that department? These are the areas that we kind of, when I go and visit these smart cities around the world, these are the 6, 7 things that I have to deal with and try to explain. So, what are the issues they face? Urbanization, old infrastructure, public safety. These are all problems that they try to solve. What is it you're trying to solve? Because when I know what you're trying to solve, I can tell you the solution. I can't tell you the solution if you say, I want smart city. This is like saying, I want IoT. What does that word mean? I want big data. What does that mean? You had to define things. The predecessors, the speakers, they all have these big definitions because they have these big machines and they have these big ideas, and they can do that. Unfortunately, we are the installers. We are the street people. So am I trying to get this smart city so that we can have a better life? Are we trying to do this so that we can monitor everything? But bottom line, are we trying to improve our citizens' lives? Is that the real goal? Digital city, I can help you. Political city, I can't help you. But if you're really trying to solve a problem, define the problem, and then let's solve it. So everybody knows it's going to be exponential growth. Everybody here talks about billions and billions and billions of devices. But you know what? Somebody has to install, monitor, and somebody has to make those, by the way. And in Taiwan, we hope that we're the ones making this billion devices. Right? So who's going to make all this? Who's going to design all this? All right. So let's talk about some kind of more use case, more defined things. So this we talked about. Are you trying to do social improvement? Are you trying to solve a traffic problem? Are you trying to solve parking, public safety? What is it you're trying to solve? These are things that people like to talk about, and they're very general. And we need to get down to, I want to do, Chengde Lu 2段几号几号. I need to get to that section and say, this is, I'm trying to solve this problem. I want to know parking problems on Zhongshanbei Lu, or, what am I trying to solve? And then, what kind of services can I give my citizens? Can we do, find parking in Taiwan? In Taipei, finding parking is very difficult. That's why I don't drive. Can you help me? And everybody talks about big data. But, and my friends at Amazon and Microsoft, they have these big clouds. There's only one problem. No sensors, no data analytics. So if you don't have the people like us who create sensors and data and transmission, you don't have anything to analyze. I call these people the pretty boys, the people who sit in a nice, 25-degree, room, 20 degrees, and sitting with the big screens. Unfortunately, people who are out installing are in 40-degree heat and top of a building trying to install something. It's not so much fun. But you have to collect data to analyze data. And that's always people just say, oh yes, we're going to have billions of devices. Unfortunately, we have to think about what that is. So what implementation? Are we talking cloud? Are we talking edge? Are we talking, is it sensors? Is it cameras? Is it video analytics? Well, everybody talks about video analytics, face recognition, car recognition, license plate recognition, all this is cool. But you got to talk about where the camera is. And how am I going to get that camera from A back? Am I going to do the analytics on the camera? Am I going to do it on the gateway? Am I going to do it on the a regional edge, or am I going to do it in the cloud? That's all different bandwidth, it's all different technologies, it's all different approaches. So you have to actually understand and plan all of this. So the critical questions that I end up asking people is, what am I going to deploy? Where am I going to deploy it? What is your current infrastructure? I love this. I was I won't say the country. I was in a country and they said, oh, we want 10,000 cameras. Sorry, it's like 100,000 cameras. They want 100,000 cameras streamed back to the data center. I said, wow, let's do the math. You don't have enough fiber. Oh, we don't have fiber. Oh, you don't have fiber. How do you expect to get all the cameras back? Okay. So they had very limited infrastructure. So you have to understand what you're working with. What kind of infrastructure? What are you trying to collect? How secure are you? We've had 2 talks here today about security and about from boot level security all the way up. So what are you involved in? How are you involved in this? What are you trying to collect? And by the way, a lot of cities we get to think they have it. They actually have to upgrade their infrastructure. They actually have some old technologies. They may have different kinds of, they don't have a lot of fiber, and that's really been a big problem. So, what are the components? So we're getting a little more technical now. I finished with the marketing. So there are a lot of components here. There are, everybody wants to do small cell LTE, Wi-Fi, Sigfox, Bluetooth, LoRaWAN, NB-IoT, millimeter wave, you got your security, you got your cameras, you got your street lamps, you got your sensors, you got your management. You can see it's very tiring. There's a lot to do here. There's a lot of things to integrate. And if you make one mistake, you compromise your security. If you make one mistake, you cannot send the camera back. You cannot even send the metadata back. So you have to be very careful in how you design each one of these components. So for LITE-ON, I'll talk about how we are working approaching this. And those of you who don't know, LITE-ON, we're one of the largest makers of street lamps. So in the US, San Francisco, LA, Boston, and a few countries, London, Taiwan, Taoyuan, you'll see Guangbao's Ludeng. So we have a very large market, and this is kind of where we think things will start. We think because the street lamp is the easiest way to get to the market. So let's think about this. My previous lives, and here at Guangbao also, was talking about doing what we call connected city. A connected city is really deploying a lot of Wi-Fi. And how do I get the Wi-Fi out there for everybody to use? Well, what's the problem with that? The problem is location. Where am I going to get electricity? Where am I going to get fiber? Well, for us in the street lamp business, that's the place. So this is our street lamp design. One of them, on the back we have our backpack, which holds our computer power. Very high quality lamp. Underneath it we have different sensors, and we'll talk about that. So this is what we showed at CES and at the Mobile World Congress in the Taipei's Smart City. So we have a street lamp that is controllable through different technologies, depending on what you're looking for. Every city, every country is different. Some want LoRa, some want Sigfox, some want Bluetooth, don't know why. And, everybody wants something different. So we have smart lamps. So a good question, and why do you want smart lamps? And we'll talk about that in a minute as to why. So then we have underneath that, we have a dome camera that helps us with people counting. Okay, so the video analytics guys can come in and do people counting. How many heads do you see? Then we have bullet cameras on the side that do license plates or cars, how many cars, parking, etc. we can do. So then in the middle, from our good partners at E-Ink, we have some digital displays. We also have active LED displays. And then LITE-ON is one of the biggest makers of car chargers also. So this is our demo that we put together. And for modules, we have a lot of different kinds of modules. We can make Wi-Fi, Wi-Fi plus Bluetooth, Bluetooth with LoRa. So there's a lot of different kinds of technology. Sigfox also. So because the problem you're going to run into is everybody's different. I said, every city's different, every requirement, every consultant they hire is different. They hired a consultant who's X from a big C company. He says, we want to do it this way. They hire somebody from Accenture, and they say, we're going to do it this way. And then we hire somebody from Tata this way. We hire somebody. So everybody's going to tell you a different idea. So the city either listens to them or not. And if they do, you need to be flexible. So we have our management platform, we have our modules platform, and then we have our sensor platform. And we'll talk about each of those. And then we have how you build out the network, how you build the infrastructure of not only controlling street lights, but also controlling all of the RF and all the other wireless technology that's around you. That's kind of important to take care of. So we can support, it's really where's the fiber. There's, you've seen the game, Where's Waldo? In Smart City, we added the game, Where's the Fiber? So we're going to actually talk about our actual product. Since everybody's talking about, bringing this all together, I actually brought a board that shows that everything is together. So we have an ARM. Where's my friends from ARM? We have an ARM processor on here. We support Amazon Cloud. We support Microsoft Cloud, Baidu, and Azure also. And sorry, Azure has Microsoft. But we support a lot of different technologies on here. And the design is because one of the things you've heard is nobody really knows what they want. So we've designed this technology to be very, very flexible so that you can put different technologies on here at different times. One of the biggest problems we have in the smart city business is we call rip and replace. So how many have been in Wi-Fi business? All right, you remember Wi-Fi, we started 802.11b, then G, then A, and N, and AC, and A. It just keeps changing. Now, when you put something up, and you put the power supply, and you put the software, everything up, and then they said, no, we don't want AC, we want AX. What do? You have to tear the whole thing down, and you have to install it again. Well, that's not very efficient for cities, because cities don't run like enterprise. The way they run their business is totally different. So you've got to support a wide range of sensors. So we can support, we have a connector here just for sensors. So we support a wide range of sensors. We support a wide range of backhaul. We have fiber optics. We have 4-port PoE Plus on here. So it'll allow you to do basically whatever kind of backhaul or whatever kind of collection you want. Now, for those of you who are a little more technical, if you just remember one thing, this is the only thing you need to remember today. So it's an edge fog device. We're part of the Edge Compute Association and the Fog Computing in Taiwan. This runs Docker containers so that when you bring your software to the game, I don't have to worry that you're interfering with anybody else. So we allow third parties to come in because smart cities require that of you. You can't say, I provide everything. Nobody does that. You have to be able to say, I'm open and flexible to other people. So and we talked about earlier, all the virtualization using Docker and then orchestration using Kubernetes. We talked about security earlier. So we do have a secure platform, chip-to-chip, chip-to-internet. And then it's a full stack router. And there's a lot of reasons for that, because the data doesn't always go where you think it's going to go. So cameras can go to the police, second camera goes to parking, third camera goes to some private company. And lastly, when you start to bring all this technology in, you've got to make sure how you manage it. You have to understand how governments respond to it, how you support it. And it's really, the software side gets really complicated. And that's why we simplified it by doing Kubernetes. Sensors, so we launched this sensor pod, and this has, this particular demo here does 22 different sensors, so we support a lot of different sensors on it. The sensor's job is to collect the data. We support both local sensors, which are sensors on the pole, and then we have some remote sensors that LoRa or Sigfox or Bluetooth or Wi-Fi, so you can have remote sensors. So there's a combination, and the answer really is you don't know. Each company, each carrier, each SI will give you a different story. And you need to be really flexible in that. We also support DSRC. LITE-ON is one of the early pioneers in car-to-car and car-to-city, so V2I work. And we've done some demonstrations. We're doing more of this very soon. And sensors. Well, one of the sensors he talked about earlier, which we didn't put on here, which is the trash sensors, the rubbish, the trash bin sensor, and how do you know how much trash is in? So we've done that for a particular customer. So understanding what inputs do you need. So if you're going to do analytics, you need to tell me what your end goal is. From your end goal, we can come backwards and figure out what sensors you need, what technology you need. So this is very important to us. So we've built one for a customer that has 22 different sensors in one pod. So some people go crazy, some people only want 3 or 4. But one of the biggest problems we found in sensors is understanding that you got to recalibrate them, understanding that sensors are have to be deployed in a certain way to get good data. So there's a lot of learnings in deploying sensors that people think they can just put a sensor out there. It collects, air quality. Well, if you don't do it in a certain way, that data is not really that valid. And then we have, quality of sensors. You can buy a very cheap sensor for $5. It will only last you a few months, and people don't know because they sold it and they left. So this is another big issue that we find. So cameras for car counting, car speed. So let me ask you a few questions. Since LITE-ON is also a big maker of traffic lights, why is it in Taiwan all of our traffic lights are 30 seconds, 60 seconds, 90 seconds? 旁边没有车子，为什么还是红灯？ I don't get this. Right? 为什么晚上半夜灯还是亮100度？ Why? Because we have no intelligence here. We don't have cameras 在数车子. We don't have cameras doing car counting. We don't know the car speed. We can't do we don't have that. When we get that, then we can decide how fast our lights change. So this is what we talk about when we talk about truly a smart city, where everybody talks about how all of this data will be and how we'll analyze it. But you got to first collect the data. You got to have the sensors out there. And you got to be the one who, when we collect the data, that we understand what is where, and the placement of technology is very important. So we have environmental sensors, flood sensors. We have different kinds of flood sensing, below ground, above ground, in the river, because you have to understand all of this. Because if the city is flooding above ground, then you have to understand where can I get the water down, so that where can I get the water to the river. So you have to understand the whole complete picture. Just knowing that one street is flooding does not help you. You need to know how to solve that problem. And that's where collecting the data. Air box, air wind, where is the pollution coming from? Is it the fact that the stoplight is 90 seconds? And at 90 seconds, I'm creating a lot of pollution. So what if I change that light to 60 seconds? Will that cut down on the pollution? Yes or no? You need data. I can tell you, I don't know. You got to have the right data. You got to collect the data. 为什么灯都是一直亮？给狗旁边的狗在看，还是 So why is it there are no sensors on these lights? So smart lights, if you use smart lighting correctly, where you have motion sensors, you have sun sensors, photodiodes, you can actually then know what lights need to be on when. So that's also one of the biggest reasons why people are replacing the current lights with these smart LEDs. So where the light is, the projection of light. Now, in our testing, and our current customers, one of the things we have found is that you can save up to 60 to 80% of your electric bill by designing it and using the right technology. So that's kind of very, very important, how you design, how you look at things. I'm getting old. So, Guangbao, we have a lot of different projects around Taiwan. This is our Leotech brand, so we do have quite a bit of activity here. Around the world, we do quite a few different technologies. quite a few different projects around the world. We have reasonable market share in the US and in Asia. But let's talk about some of the more important things. The number one need right now in Asia, especially in China, the talk, is about public safety. That's the number one conversation now. So again, public safety means what? Cameras, which means you need to have some kind of analytics on the device. Or are you going to backhaul that? What are you going to do? What kind of technology? You know, it's funny, one of the biggest requests we get is for guns from the US, only from the US. The number one sensor from the US request is gunshots. 为什么我不住美国? Okay. If people have to come to you and say, yeah, we need gunshot sensors, there's a reason you don't want to live there. So gunshot sensing is a very big high demand right now. So a lot of this AI software, there's a lot of companies doing it. We look for partners who do this technology because we do just some of it, very little of it, but we really rely on partners. Now, there's a lot of rules when it comes to partners because some countries want their own. Like China prefers to have Chinese vendors, so we accommodate those kind of vendors. EU doesn't want certain countries, so we have to accommodate them also. So traffic, number one problem in most of Asia. Actually, when you talk to most people around the world, even Europe, traffic is a problem. Now, I can't wait till we have our NVIDIA autonomous driving car, which is an Audi. Volker is a good friend, spoke earlier, talking about the 2025 purely autonomous car. You know, that's a great idea, because then I don't have to worry about parking, I don't have to worry about stress. I can just get in my car, have a cup of tea, go to work. So until then, until 2025, we have a lot of problems. One of the biggest problems will be when we have the crossover between self-driving cars and human driving cars, because humans get angry. Humans react. Right? We react differently. We don't react like a AI, like a robot. The reason why I only like robots, because they're predictable. Put the right sensors. But between now and then, we need to collect a lot of data. We need to actually know what streets should be one way. Now, once we have the cameras out, from now until 2020, 2022, we can collect enough data that we can analyze it and say, okay, 这条路是单行道，这条路是 from what time to what time is one-way street? From what time it could be two-way? Hey, I can't make that decision. That's not my job. My job is to collect the data, transmit the data. And some of you out there with your pretty suits on can sit in a nice cool room and do that. So traffic density, traffic flow. Now, what we do today is we send somebody out to the street with a little thing. We get the students, right? And we put them on the street and we say, please count how many cars. Well, the problem is they're not doing it 24 hours a day. They're only doing it for a couple of hours or 3 hours. 5点到7点, they're doing this high peak time. They want to know the high peak. Well, there's also the low peak. What happens to the traffic? I want to put this red light violation in China. I think I'd make a lot of money. I'd put it in for free and just get paid from the traffic tickets. I think I'd make a lot of money. Illegal parking, I can make money in Taiwan in that. Just looking at how many people are doing illegal parking. Speeding, late at night, we get a lot of that. So again, Guangbao, our core is the lighting, the sensing, networking, and the surveillance piece, the cameras. So this kind of shows our catalog of all the things we do and how we put it all together. So when people come to us and they talk about what they really need. So for those of you who don't know LITE-ON, so LITE-ON has been around for a long time. In 1975 we began out in Zhonghe. We're around a 43-year-old company for Taiwan. We're the first 股票, we were the first technology stock in Taiwan. And we're a member of the Dow Jones Sustainable Index also. We've been around for about 43 years, so about younger than half of you, older than half of you. We've got companies and offices around the world. We have factories all over the world. We have about 50 factories in China alone. So we have a lot of people around the world. And in our group, so I work in the SLA group, we focus on things that could be smart. So for example, industrial automation, where we can get into robots and factory automation, Factory 4.0 team. Our video surveillance, making different kinds of cameras, different kinds of technology. Our communication module team, which is one of our leading teams, we do huge volume. We do about 64 million of these communication modules a year. So we're looking for people who can handle this kind of volume. We've done about 2 million streetlights already, and we're looking to grow. And then the networking side, Wi-Fi, Bluetooth, LoRa, Sigfox, blah, 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 blah. I just say blah, 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 because if I say Sigfox, you say LoRa. If I say Bluetooth, you say Wi-Fi. Okay. That's the problem. That's why this board is done in a modular way, because there is no Wi-Fi on here, there is no Bluetooth on here, there is no LoRa on here. These are all snap-in modules. Okay, it's all snap-in technology. The core is the same. My friends from ARM are right in here. We also do a lot in automotive in our group. We won't talk about that today. And with that, I'm actually 8 minutes ahead, so I finished on time. Thank you, guys.
Thank you very much for joining us this afternoon, Bruce. And ladies and gentlemen, the last but definitely not the least speaker of the forum will be Carl Koken, General Manager of IoT Partner Devices and Solutions at Microsoft. Carl, together with his worldwide team, enables partners to build IoT solutions using Microsoft's Azure cloud services, Windows, and open source technologies. The solutions range from smart refrigerators to industrial process automation systems. So ladies and gentlemen, today he will talk about hybrid cloud and the intelligent edge. Now let us give him a very warm welcome.
It's getting late. It's always great to be last. The good news is everybody's kind of finished up really early, so I get to use the entire rest of the time. So I'm going to extend from half an hour to an hour. No, I'm not going to do that. So first, I'll say, 谢谢. Thank you very much for being here. Thanks for putting up with all of us for so long. Thanks for staying throughout this presentation. So one of the things that was mentioned in my bio was I get the opportunity to work with partners every day. That's my entire job. That's my entire team's job. It's part of what we at Microsoft do with our partners is we deliver a platform that other people build on top of. So the solution isn't from us, as the previous speaker talked about. We're not building the solution. You are. And so I can't agree more, right? But what I wanted to talk about today is one of the things that's been rapidly changing in our industry is that when we first started talking about cloud computing, that meant everything had to be connected directly to the cloud, right? Well, that's not reality, right? You've got to be able to do things that are on-premise for a variety of different reasons. And so there's been a lot of changes over the last couple of years. I mean, shoot, take a look around at all of the booths that have been here at COMPUTEX. This is actually my first time at COMPUTEX in about 4 years. And really the reason for that is I'm in IoT, not PCs, right? So COMPUTEX was very focused on PCs for a number of years. Last year, there was a big change at COMPUTEX where there was a lot of IoT. You look around at all the booths that are out there on the show floor, and it's a ton of IoT. Now, what we'll go through is a little bit about what's changed. What's that use case? What are the requirements? So a little bit about why are people thinking about hybrid? Why are they thinking about intelligent edge computing? And then also I want to go into a little bit about why customers, what the conversations we're hearing from customers, and then kind of talk through what about IoT, right? So a lot of times we talk about cloud computing, we talk about hybrid, we end up talking about IT. And that's not what we're here to talk about. We're here to talk about IoT. And then I want to talk a little about the different patterns. As the previous speaker talked about, nobody's the same. Everybody's a little bit different. Even within some of the partners that we work with, one of our partners is Emerson. Emerson is one of the world's leading process automation, process manufacturing companies. They service and sell solutions to oil companies, to chemical companies. Well, you know, there's a refinery, there's an oil platform right in the middle of downtown Los Angeles. You'd never see it. You drive right by it, you'd never know it, right? But the oil company that runs that platform has great connectivity. They've got a fantastic way of connecting up. There's tons of bandwidth in Los Angeles. But then that oil company wants to go and build that same platform in a compound in Angola, where they don't have connectivity and it's only through satellite. So we'll talk a little bit about some of those kind of things that we're hearing from our customers and our partners about how they go and put that into play. And then, you know, I do have to do a little bit of a Microsoft commercial, sorry. So let's touch on a couple of the three use cases, really. You know, if you take a look at what people are looking for in a hybrid solution, is that at the edge, a lot of times it's intermittent connectivity or it's no connectivity. That's why you want to have some intelligence down at the edge, right? The other reason could be regulatory requirements. It could be that that you've got to, for privacy purposes, keep the data local. If you're doing video analysis, you can't send the whole picture in Europe, because of GDPR, up to the cloud. It has to stay local. And eventually you have to get rid of it. So you've got to make sure that you're adhering to the different regulations. And then some of it has to do more with how you're going to create the solution that you're building. And maybe you want to have the cloud application up in the cloud and the data local. But in each one of these, you might want to have some of that information local and be able to go ahead and deliver more real time to the customer. And that's really about these hybrid requirements. When we talk about a hybrid solution and the requirements for a hybrid solution, it's really only three things, right? It's about having a consistent application development environment. I want to use the same tools, I want to use the same techniques, I want to use the same languages, I want to use the same models, whether I'm putting it up in the cloud or I'm going to put it on premise. I want to be able to use everything and do everything the same. I don't want to have one set for one part of my solution and another set for another part of the solution. So I've got to have that consistency of the tools. But then I also want to have those cloud services available on premise. So if I'm going to go build a solution and I require streaming analytics, well, I want to make sure I have streaming analytics in the cloud. I want to have it on premise as well. I want to have machine learning in the cloud. I want to be able to implement that model on premise as well. So you can't have it in just one place. You want to have it in both. So that gives you the flexibility of building that solution. And then you have to have an integrated delivery experience, right? You got to be able to deliver the services, deliver the application code, the updates, any of its devices, firmware. You've got to be able to deliver that regardless, whether it's going to be delivering some of those to a public cloud service or to a service that's sitting on premise. So again, there's those three things have to be there for what our customers are asking for when they talk about a hybrid cloud experience. Now, the other thing that we have to think about, and this is kind of a simplification, you know, we're talking about everybody's different. Everybody has a different solution. Everybody has a different way of implementation. But you want to be, you know, when they go and implement a hybrid cloud solution, they want to have the resources on both clouds, whether it's a private cloud that's sitting on premise or it's in the public cloud. They want to make sure that resources that they need are available in both places. In some cases, they want to make sure that the resources are spread across clouds. So maybe I have some of my data in one cloud, some of my data in another cloud. I have an application in one, I have an application in another. I have the machine learning model in one. I'm doing video analytics on premise. I have the data, the metadata sent up. I do the analytics on the metadata up in the cloud. And then if I've got multiple types of clouds, I want to have seamless connectivity between all of them. I don't want to have to worry about, did I get access or not, right? And so each one of these, and frankly, there's a lot more, we want to make sure that when you're developing a hybrid cloud solution, that you take that into account. So when you're talking to customers and when you're building a solution, when our partners build solutions for those customers, they want to make sure that they're able to have that flexibility in the solution that they're building. Now, if you've wandered around the floor, you've probably seen a lot of these different types of solutions. You know, there's all the retail solutions and the like. So at a high level, they're all trying to figure out, all these customers trying to figure out how do they enhance their business. So when it's retail, they want to make sure that they're offering better services to consumers. There's a department store down the road from me. My daughter worked there one summer, and one of the things she told me was that it was really interesting. Between the hours of 3 and 5, the primary set of customers that walked in the door were young Indian women with young children. There's a large Indian community near the store. And then about 6 or 6:30, the type of customer changed. Now it was Asian and Caucasian females, primarily, along with the rest of their family. And so there was a big change. Now, what would you do if you knew that? If you knew that one type, one ethnicity, one gender, one group of people was coming in at one time of day, versus what would you do if a different one is coming in another time of day? Would you change the prices on some of your products? Would you go and offer a different sale on some products? Would you change how the shelf looks? Right? So all of that information are things that they want to be able to have access to in order to be able to provide better service to their customers. On energy, you know, if Tesla is successful, everybody's driving an electric car tomorrow. What happens after right after 5 o'clock? Everybody drives the car home, plugs it in. Now what happens to the electric power grid? Right? So you need to have a way of understanding what's going on. If you could understand with that car, maybe it's not fully discharged, so I only need to do a trickle charge to it. Another car might be needing a fast charge. But even now, being able to understand when you need to have peak hours and when there's lulls. You know, we've had situations in the past where my parents live is in the northeast of the United States, and when they take the power plants out of service for maintenance is in the spring, because the weather's still relatively cool, so nobody's got their air conditioners running. It's not cold enough where they have to run the heat. Well, they had a heat wave in the spring. Everybody turned on their air conditioner. They had a brownout because there was no expectation or understanding of how the weather might impact the maintenance schedule that they had. Right? Again, all of these, I'm not going to talk about smart cities. The person from LITE-ON, he spoke really well about that. But you also have the agricultural side or healthcare. You know, I was meeting with one of our partners on the healthcare side, and one of the things he was talking about is elder care. Right? One of the challenges around the world is we have a huge number of folks that are reaching the age when they're going to retire, and unfortunately at that age there's also healthcare issues. And how do you help them to stay at home? And so a lot of the different partners that we work with are trying to figure out different ways of doing things. How do they monitor folks, but also how do they do it without being intrusive? How do they do it that adheres to regulations? But also, you even go next step. One of our partners, Siemens Medical, they have a solution called Team Play. If you're all in the more industrial side, you remember the term business process management, business process automation? They're starting to think about that in healthcare. When you check in at the front desk, they want to know how long it took from when you checked in to when they took you to the examining room. They want to know how long you sat in the examining room in that really pretty gown, and want to know how long it took you to go into, say, the MRI machine. How long were you sitting there before the MRI machine turned on? How long before you got taken back out? There's two things that are really important to them. One is your satisfaction. So if you're not sitting around cold in a dark room for 2 hours while you're waiting for the doctor to show up, you're much happier. You're better able to take care of yourself, explain things. You're not going to be upset. Second, an MRI machine is really expensive. If you can keep it running all the time, you get a better return on your investment. So again, in all of these cases, it's all about how do I provide a better service to my customers, whether you call that customer a patient or you call that customer a farmer. And when we think about IoT in the cloud and IoT in the edge, there's a number of different things that go into it. Typically, when we've talked about IoT in the cloud, we talk about remote monitoring, remote management, taking data from multiple sources and bringing it all in one place, and then also infinite compute. We're in 50 different countries. I don't know how many data centers anymore. There's another one opening up every day, it seems. We've got, I think we're the first one in the Middle East. But we've got tons and tons of storage. There's tons and tons of compute. That's fantastic. That's helpful for being able to do what you need to do. On the edge, the reason that people want to have something on the edge is because they need more, they need the information, they need something now. And you guys live in the industrial automation world, a lot of you. So that's why we say near real time. We all know that real time is not real time. But they really want to have information as quickly as possible. You want to give the plant manager the knowledge that there's going to be a problem on the line. You want to know at the steel plant that one of the presses, the steel presses, is having a problem. And you want to do it right away so they can respond very quickly. You want to be able to do pre-processing. We talked about the video analytics. You want to pre-process that data, make it more available for everybody, but make sure that you're only sending the data that is appropriate up into the cloud. You want to be able to do that using the intelligence on the edge. You want to have machine learning, artificial intelligence, analytics, and you want to do it in a secure manner, but you also want to make sure you can do it offline, whether that's offline forever, intermittently offline, either case, you want to be able to do that. And then also, I think one of the things that people forget, because in the technology business, we figure everybody just upgrades, throw out the old thing, bring in the new, right? Well, there's a whole bunch of stuff already installed. If you go to any building, they already have sensors installed. They already have information in there. And it's using an older protocol. It's using BACnet, or it's using Modbus. Yeah, we'd love them all to move to MQTT because it's more secure, it's a better protocol, but they're not there yet. You're not going to rip everything out. So in many cases, you have to do protocol translation. So one of our partners is ThyssenKrupp. They build elevators. They've had sensors on those elevators for decades. Absolutely decades. The problem is that all those sensors haven't been sending the data anywhere. And it's a huge amount of data. All those sensors communicate via BACnet. So you want to be able to take that information, take it from BACnet, and transform it into a more secure protocol. In their case, they're using AMQP. So in this case, it's, let's do that protocol translation, but also you got to do data normalization, summarization, aggregation, things like that. And then, of course, privacy of the data, protection of IP. You want to make sure all that's done on premise. And you want to make sure that everything is consistent, whether it's up in the cloud or on premise. So let's talk about some of the patterns. I'd love to say these are the only ones. These are predominantly the ones that we've been running into. So when we talk about some of them, and we tend to call them foundational patterns, we have hybrid apps. You want to have those hybrid apps even in a private cloud or in a public cloud. By the way, Azure Stack is Azure running in your data center. So this is take our cloud services, put it on a rack, stick it in your data center. But in this case, this is just site-to-site VPN. Let me make sure I've got communications, secure communications back and forth. And then there's also the other side of this, which is build an app, single code base. I want to have continuous integration. I want to have continuous deployment. And I want to do that regardless of where it is. But I want to be able to have that code base deployed anywhere. So again, the same code base, have consistency between whether it's on-premise or in the cloud. Dev test, I think one of the previous speakers spoke about this. We see this a lot, where people are doing their development and their tests in the cloud and then doing the deployment on-premise. And so we want to make sure that you have that ability to be able to do that kind of a pattern. And so when you're talking to your customer, that's part of what you're asking for is what are you trying to accomplish? What are you trying to do? There's also burst. Back in the day, You'd have a data center. You built your data center to handle the worst case scenario, right? It's the end of month, end of quarter, end of year close. Everybody's going to be hitting the SAP system. I'm going to have servers up the wazoo, technical term, and we're going to have huge amounts of servers to handle just that peak, right? Well, that's overspending. One of the benefits of the cloud is that you don't have to have everything to handle the peak. You can burst to the cloud in order to be able to handle the peak requirements. And so that's the intent, is to be able to work on the premise, be able to do what you would do normally, and then maybe you're a retail system, you're running a big sale, or it's Christmas, and now you need access to more storage, more compute. I can go and burst up to the cloud for that. I've mentioned a couple times keeping the data local or keeping the solution local. Well, one of the pieces that you'll see is when you talk to customers of manufacturing, they've got petabytes of data. Large manufacturers have tons and tons of data. And all that data is their historical data, stored in OSI Soft Pi or some other time series database. Well, they're not going to take all that data and put it up in the cloud. One, because it'd take forever. It would take years to move all that data up in the cloud. Two, there's no goal, there's no purpose for doing that. You can leave the data there. You can have the application running in the cloud and accessing the data that's on premise. So again, whether it's because you already have a huge amount of historical data that's sitting on premise, or it's because of regulatory concerns, you can have the data. You can sit up in the cloud with the application, but then access the data as needed. Another one is of course having artificial intelligence on the edge. In our case, we have something called Azure IoT Edge. So in this case, it's basically a set of Docker. We use Docker as the platform for storing the containers. But again, it's running those services in those containers on the edge, whether it's our services or somebody else's services. But being able to have that in a remote location, being able to have it mobile, being able to have it in some place that doesn't have great connectivity. And so being able to have that specific set of services local is important, but maybe they don't need to have all of the services. They don't need to have all of the infrastructure. You can do that too. And you can also go ahead and train the machine learning model up in the cloud, and then once it's trained, push it down. And I'll give you an example of one of our partners that's doing that and how they're going about it. But that's a big part of this is go ahead and leverage the cloud to train the model, push the model down. Again, you can only do that if the machine learning models are the same and if you can deploy them that way and you can use the same tools. And then you've got geographically distributed applications. A lot of our partners are global in nature. I've talked about a few of them. We've got a number of partners here. Everybody's global. Everybody's got facilities everywhere. You want to be able to have an application that's distributed. You want to be able to deploy it where your customers are. When I talked about Emerson, they have customers that are huge oil companies. They're located everywhere. They want to be able to distribute that application so that the latency for the application is as low as possible, and so they want it to be distributed wherever they need it. So whether that's on-premise, whether that's up in the cloud, whether that's in a cloud in the UAE, in the cloud that's in China, in Tokyo, doesn't matter, right? So I mentioned before, I was going to talk about a customer about how they've implemented an edge solution. And regardless of the technology, what I wanted to talk about is why they were doing it, right? So you probably all have heard of Schneider Electric, one of the largest industrial companies in the world. One of the things they do is they build solutions to be able to manage manufacturing, process manufacturing or distributed manufacturing systems. In this case, what they were concerned about was oil pumps. Oil pumps are located all over the place, typically in very rural areas. And in their case, what they were concerned about was, how do I know that everything's going well? The oil pump is located in the middle of nowhere. There's not very good connectivity. How do I know that it's okay? So one of the things that they wanted to understand was, let me take that data. I've already got the data being transmitted from the device. The problem was it was using Modbus. So for them, what they needed to do was figure out how to go and translate that from Modbus to be able to do anything with it. So for their SCADA systems, what we helped them do was create a Modbus protocol translator. So they use the Modbus protocol translator to pull the data off. These are, they call them Dynacards. And so at each one of the well sites, they put a gateway device. That gateway device could be from Nextcom, could be from AdLink, could be from Axiom Tech, any partner, Advantech. We've got tons of partners that are certified that have them. It doesn't really matter. The point was really, what are you going to do with it? And so the first thing is take the data off, translate the protocol from Modbus to something better. In this case was MQTT. Then go and run it against our machine learning model to be able to determine if there's a problem. So what we did was work with them to go ahead and build that machine learning model, and then you take that model, you build it in the cloud, you push the model down. But one of the things you have to do is you have to have continuous learning. The models don't get better unless there's lots of data. The problem that they ran into is it's intermittently connected. Right? You're not going to always have a satellite uplink running off of every single oil pump out there. And so what they're trying to do was get that data off, do some processing, and if there's a problem, alert somebody and make sure that they're aware of it, regardless of whether they're connected or not. But what they ended up doing as well was when they get connected, take that data and pass it on up to the cloud so that it can continue to learn and update the model and then push that model back down after it's been updated. The information, the alerts, would go to one of the operations personnel. That operations personnel can then take a look at the SCADA system to see what was going on with the pump and then be able to go ahead and either send somebody out or make some changes as needed. So that's why you want to have something that's on premise. It's to be able to do something whether it's connected or not. I'll give you another example that's local here. So I can't unfortunately tell you the name of this steel company. It's one of the largest steel companies in the world, based here in Taiwan. This is their hot rolled steel mill. Sorry. This is their hot rolled steel mill. One of the great things about my job now is I was used to working in a clean environment. You're right, sitting on my butt in a nice air-conditioned building, and it was all beautiful. Now I get to go to hot rolled steel mills in the middle of summer. It's a little hot. So that red stuff there, that's molten steel. So one of the challenges when you're looking at something like this is how do you know when one of the presses or one of the rollers is having a problem? So one of our partners, XWin, another local company here, actually if you go by our booth, they've got a demo there. They actually spoke in our booth yesterday. But what they created was a predictive diagnostic model. And that predictive diagnostic model enables them to be able to pull the information off. Again, we're talking about a partner who understands the hot rolled steel mill. We don't know anything about a hot rolled steel mill. He understands how to determine via vibration or acoustic analysis what's going on. Now the big challenge for folks like this is, you notice I'm the only dummy that's here, and I'm up here in somewhere up here on a catwalk. There's no people down there. The plant is fully automated. You have somebody sitting in a booth watching everything and monitoring everything, but there's nobody down by those machines. A lot of those presses have been running for decades. 7x24, 365, they never stop. Okay, they stop for downtime for maintenance, but planned downtime. So one of the things that they did was they created a solution where they pull the data off of sensors that are on each and every one of these. And there's Dr. Wong. I didn't want to put a picture of me in there. So he's pointing at his gateway. So that gateway has the analytic model on it to be able to pull the data and tell you whether there's a problem or not. Good example for them was when he was pulling the data, one of the things they found was there was a problem with one of the presses that it was not vibrating properly. So he was able to spot the anomaly. They sent somebody out. It turned out that the bolts holding the press into the floor were rusted. So they were able to plan the downtime, replace the bolts, because downtime for any one of these manufacturers is millions of dollars, right? And so for them, for this particular steel company, it was a great opportunity for them to be able to resolve the issue before there was a real problem. But the model was put there into the gateway. The gateway is connected to all of the sensors on there. And oh, by the way, you can't tell, but that gateway is sitting down 3 stories below the floor. Right? I think this gateway happens to be from Axiom Tech. And so it has to be hardened. It has to be able to work in a really dirty, dusty, dingy, greasy environment. And so that's part of the challenge, is you got to get the device that's going to fit properly, have the right sensors on it, be able to communicate. He's got the model. It's sitting in there. He continuously learns from that model. The reporting comes from the cloud service and does all the alerting. So it's connecting up wirelessly to the cloud service, but it happens in this case to be wired to the sensors. So as you can see in both these examples, there's a couple of different things going on, right? The first one, let's do protocol translation. I'm intermittently connected. I want to be able to get information from there, build my models, push them down, do something on premise. In the second example, it's a little bit different model, where I'm getting the data from all of these different presses. I'm getting the data from the sensors that are there, and then I'm doing my artificial intelligence, my analytics locally, so that the plant manager can go and take action quickly. So, and that's really, when we talk about hybrid cloud and intelligent edge, that's really what it's about, is being able to provide our partners with the flexibility to build a solution that makes sense for their customers. So, now it's time for my commercial. So, we're over in Nangang, but I've only listed out a few of the services that we offer. So at Microsoft, we have operating systems. We have Windows IoT Core, which is a free operating system for operating on small devices. It takes all of the knowledge, learning that we have about security for the last 20 years and puts it in there. We also have our SDK for making it easy to connect up devices, whether that's running Windows or RTOSes or Linux. It doesn't really matter. We have over 1,000 devices that are on our catalog for certified devices. And we also have a security program. So when our partners go and build a solution, we can refer you over to other third parties that can do an audit and ensure that you've built a secure solution. The Azure IoT Edge I talked about, that's one of the tools or the runtimes that we've got that enables you to run containers with all of those services that you'd like to run that are consistent with what's up in the cloud. Azure IoT Hub is where we pull in all the messaging. That's how we do the deployment. That's how we do access and secure the systems. And if you take a look, we have provisioning services and device management services, the analytics services. One of the big challenges is cloud services in general come out every few months. We do updates every few months. We do new services every 6 months. I can't list all of them here. There are hundreds. But there's also the other side of this, which is how do I go and visualize the data? So it's back to, you got to make sure you're able to visualize it properly and understand it. When we talk about our suite, we have a bunch of what we call accelerators that make it easy for you to be able to do some basic things. Remote monitoring, predictive maintenance, and we call connected factory. So OPC UA is certainly supported, but we also want to provide you ways to simulate devices that are connected. And then we have all of these services in, I guess the good way to phrase it is a bespoke solution. So when you want to build something, have everything custom, you can go and mix and match everything that you need. We also have a SaaS service called IoT Central. Again, you can go by our booth. Hopefully you'll get a chance to stop by there. You'll see a number of our partners with solutions. The thing to take a look at is the different model that they use to build a solution. Why did they do that? What was the real reason for it? You'll see a lot of the patterns that I talked about here, and you'll get a chance to learn more about our technology. So thank you. Stay safe. Thank you very much for your time.
And thank you, Carl, for joining us this afternoon. With that, ladies and gentlemen, we conclude the 2018 COMPUTEX Forum. 各位在场的所有贵宾，还有所有的媒体朋友们，我们今天的 COMPUTEX 论坛到此正式的圆满落幕了。我们能够来趁这个机会提醒您， 请您为我们到线上来填写我们的问卷，凭荧幕的截图到我们1楼的服务处可以兑换杂志1本。同时也请您在步出会场的时候，将您现在身上所佩戴的名牌交给我们现场的工作人员，我们要进行名牌的回收。再次的感谢各位贵宾今天的与会，敬祝各位贵宾在 COMPUTEX 期间参展愉快，谢谢。